Okay, so in this video, we are going to go over upcasting and downcasting. But to start off, what we're going to do is we're going to go over some sort of like refresher stuff about references and how Java sets things up in memory. And I think that'll lead to an easier understanding of upcasting and downcasting. So for this example, we have a shape object. It's a simple Java class. It has one attribute, color. It's got a getter. It's got a setter. It's got a constructor. It's got a toString method. And it has this public double compute area that doesn't do anything. Okay. Notice we haven't made this class abstract. We don't have any abstract methods. This is just a simple Java class for shape. Okay, and now we have a second Java class called Circle, which extends shape. So Circle is a subclass of shape. All right, this adds an attribute called radius. It inherits all of the properties from shape. Okay, and it has a getter and a setter for the radius. It has a toString method, and you'll notice that it also has a compute area, public double compute area method, just like shape did, public double compute area. Okay, so this circle class has overridden the compute area method that was originally defined in shape. Okay, so these are the two classes that we're going to be talking about. And now I'm going to briefly switch over to some diagrams that I've created that hopefully illustrate the concept of what's happening in memory, which I think will lead to a greater understanding of references and casting. So let me just go over here really quick. Okay, so what I have depicted over here on the left is what's going on in memory. Okay, and when I execute this statement, remember, everything to the right of the equal sign determines what happens in memory. So when I say new shape, that's basically saying, all right, I'm going to reserve some space in memory to store a shape object. And then over here, it just says, all right, I'm going to refer to that blob in memory as S1. Okay, so now I have this spot in memory. It's reserved. I've got a place to store color. I've got these functions that I can execute. And that's what's happening in memory. All right, and if I were to create multiple shapes, again, over here to the right of the equal sign, you see I've got three new shapes. So I've created three blobs in memory, and then I'm referring to them as different things, S1, S2, and S3. So this should all basically be a review. Okay. Now for a circle object, remember, circle is a subclass of shape. So when over here to the right of the equal sign, when I do new circle, what that's saying is, all right, I'm going to reserve a big blob of memory for a circle. But a circle consists of a shape as well as some additional stuff added to the circle. So remember, when we had our video about constructors, we pointed out that when you actually do this new circle, it's actually instantiating a shape behind the scenes. So that's what I've depicted here. So this new circle creates space to have this whole shape object. Okay, and it also creates space to store all these circle-specific things like radius, get radius, etc. All right, now there's two methods in here, compute area and toString, which have been overridden in circle. Okay, and so that's why I've sort of colored them the way that I did with these lines. All right, and what this basically means is that for compute area, if I were to call compute area on this object here, Java is smart enough to say, all right, well, there's a compute area in shape, but there's also a compute area in circle. So in this instance where I have this circle object, I'm always going to call the circle version of compute area. Okay, and we'll see that in a second when we start talking about casting. And it's the same thing with the toString method. Even though there's a toString method defined in shape, because I overrode it in circle, now when I call toString, I'm always going to use the circle version of that, okay? And so again, we'll see that at work in just a second. And then this slide basically shows that if I create multiple circle objects, again, I've got a new circle and a new circle, that just reserves space in memory for all of this stuff, okay? So now, here's where things start to get interesting, okay? So I have a shape S1 equals new circle. So we're going to start again to the right of the equal sign, and we're going to say, all right, so new circle means that in memory, I've created this blob that will hold all of this stuff that pertains to a circle, which includes this shape superclass. Okay? But now this time what I'm doing is I'm referring to all of this stuff in memory here as a shape. Okay? So when I do that, when I create a circle in memory, but I refer to it as a shape, what that means is that this S1 reference only refers to the stuff that pertains to a shape. All right, so I'll say that again. So even though I have this whole circle in memory, okay, I've instantiated, when I did new circle, that instantiated this big blob of memory that stores all of this stuff for a circle. I'm referring to that blob as a shape reference. So S1 is a reference to a shape. So S1 is only referring to this portion, the shape portion of this object. So what does that mean? Well, it means that I can execute statements like s1.getColor. I can do s1.setColor. Okay? It means I cannot, if I was to try and do s1.getRadius or s1.setRadius, I would not be able to, because getRadius and setRadius are circle methods, and I am referring to this as a shape. Okay? And it also means that if I was to try and call compute area, because again, I've got a shape reference, and shape has a compute area, and shape has a toString. If I was to call s1.computeArea, Java would say, okay, I know there's a compute area in shape, but you aren't really a shape, you're really a circle. So I'm going to actually execute the compute area that's down here in circle. Okay, so if I did this line of code right here, s1.computeArea, that would actually execute this function, compute area, that's defined in circle, even though I have this shape reference. Okay, and same thing if I did s1.toString, okay, the toString's defined here in shape, but it would say, well, okay, you're not really a shape, even though you're referring to yourself currently as this shape s1 reference. Really, when you say toString, you're talking about this toString that's defined in circle. Okay, so this slide right here is sort of critical to understand, and it makes understanding casting a lot easier. When I refer to this blob in memory as a shape, I can only execute the functions that are inside this blue box. But some of the functions, like compute area and toString, actually have been overridden. So even though I want to execute compute area, really what I'm doing is I'm executing the compute area that's defined in circle. Okay? So in the next video where we talk about upcasting and downcasting, I'm going to actually show you some coding examples of how this works.